Hello everyone, still on binary operations. In this tutorial, I would like to talk about the commutativity property of binary operations. It stated that for all elements or members A, B of a non-empty set S, A asterisk B is always equal to B asterisk E. This asterisk, remember, it is an operation. It is always defined. It could be plus, minus, multiplication, whatever. So provided the two elements are from the same set, whenever you connect them with such operation, it is equivalent to reversing the elements with the same operation. If this condition holds, then we say that that operation is commutative under the set S. It could be real number, natural numbers, integers, and so on, right? So in this tutorial, I would like to take different set of numbers to test for commutativity under the four basic operations. So let me take real numbers, for instance, under addition to see whether it is commutative. Whatever number you take, provided it is a real number, like 2, you add it to another real number, 3. This is the same thing as 3 plus 2, right? Reversing the numbers will not change the value because this is still equal to 5, while this is also equal to 5. Nothing will change. Therefore, we said that addition is commutative under the set of real numbers. This is how to conclude. So under the set of real numbers, plus is commutative. So addition is commutative under the set of real numbers. Or you can simply write it as, you can write it like this. Yes, something like this. Addition is commutative under the set of real numbers. Now let us test for subtraction. Take any real number, for example 5. Subtract any real number like 2. Is this the same thing as 2 minus 5? Let's confirm. To the left hand side, we have 5 minus 2, which is 3. To the right hand side, we have 2 minus 5, which is negative 3. And you can see they are not the same. And this is the same thing for all values you take. Subtraction is not commutative. Therefore, we say that subtraction under the set of real numbers is not commutative. What about multiplication? Take two numbers like 2 times 3. Is this the same thing as 3 times 2? Yes, definitely true, because this is 6, this is 6. 0 times negative 5 is the same thing as negative 5 times 0. So in general, multiplication is commutative, and you can test for various numbers. So multiplication under the set of real numbers is commutative. What about division? Division is not commutative, but you can find out. Is 2 divided by 1 the same thing as 1 divided by 2? This is 2, but this is 0.5. You can see they are not the same. And this is true for all numbers. 25 divided by 5 is not equal to 5 divided by 25. And therefore, under the set of real numbers, division is not commutative. What about if you have integers? The set of integers under addition, is it commutative? Well, let's find out. Minus 2, which is an integer, plus 5, which is also an integer, is equal to 3. What about 5 plus minus 2 is also equal to 3? And you can test this for all integers and it will satisfy. Therefore, the set of integers under addition is commutative. Or let me say, addition under the set of integers is commutative. What about subtraction? Don't even waste your time. It's not. The same thing, it follows the same strategy for real numbers. Multiplication under the set of integers is commutative. What about division under the set of integers? Division is not commutative. You can try that. It's not commutative. Let's test for natural numbers. Natural numbers can behave similar way with real numbers. Natural numbers, remember, they are the counting numbers. If you take a natural number like 5, you add it to 2, this is equal to 7, and 2 plus 5, this is also equal to 7. So addition generally is commutative. What about subtraction? Subtraction is not. It's not commutative. Multiplication is commutative. Take any two natural numbers. 100 is a natural number times 2 is the same thing as 2 times 100, provided the two are natural numbers. So this is commutative. And let's test for division, which I know is not. Division is not commutative. It's not commutative, because you may have 4 divided by 2, which we know is equal to 2. But 2 divided by 4 is equal to 0.5. You can see the values are not the same. Therefore, division is not commutative. Now, I like to take a finite set, like a set S that has entries 1, 2, 3, and 4. What about addition under this set? Every two values you take here, 2 and 3, you add them. For example, 2 plus 3 is 5. 3 plus 2 is also 5. So this is commutative. And subtraction is not. Is not. Because like 1 minus 4 is negative 3. But 4 minus 1 is positive 3. You see that? It's not commutative. Multiplication is 1 times 4 is the same thing as 4 times 1. 2 times 4 is the same thing as 4 times 2. All right, so this is commutative. And division is not. So you can see that division always fails. Likewise, subtraction. So this is what you should know about commutativity. The moment you reverse the values, you get the same thing. Then it implies that that operation is commutative, and otherwise it is not. In our next class, we are going to talk about the associativity property. Thank you for watching. Do share to your learning colleagues. Bye-bye.